Hi, welcome back for section 3, Drifting Continents. Today we're going to talk about what was Alfred Wegener's hypothesis about the continents, what evidence support Wegener's hypothesis, and why was Wegener's hypothesis rejected by most scientists of his day. Today's key terms are continental drift, Pangea, and fossil. 500 years ago, the sea voyage of Columbus and other explorers changed the map of the world. The continents of Europe, Asia, and Africa were already known to map makers. Soon, map makers were also showing the outlines of the continents of North and South America. Looking at these world maps, many people wondered why the coasts of several continents matched so neatly. For example, the coast of Africa and South America looked as if they could fit together like a jigsaw puzzles. In the 1700s, geologists thought that the continents had always remained in the same place. But early in the 1900s, one scientist began to think that the continents could have once been joined in a single land mass. Okay. Continental drift. In 1910, a young German scientist named Alfred Wegener became curious about the relationship of the continents. He hypothesized that Earth's continents had moved. Wegener's hypothesis was that all continents were once joined together in a single landmass and have since drifted apart. Wegener's idea that the continents slowly moved over Earth's surface became known as continental drift. According to Wegener, the continents drifted together to form the supercontinent Pangaea. Pangaea means all lands. According to Wegener, Pangaea existed about 300 million years ago. This was the time when reptiles and winged insects first appeared. Tropical forests, which later formed coal deposits, covered large parts of Earth's surface. Over tens of millions of years, Pangaea began to break apart. The pieces of Pangaea slowly moved toward their present-day locations. These pieces become the continents as they are today. Wegener gathered evidence from different scientific fields to support his ideas about continental drift. He studied land features, fossils, and evidence of climate change. In 1915, Wegener published his evidence for continental drift in a book called The Origin of Continents and Oceans. Okay, this is what he thought the continents looked like. And what's important is that you can see here that this is the Mesosaurus fossils are found in South America and Africa. Okay, and this was also a folded mountain. Okay, notice that the coral beds kind of go around all the continents there. Okay, notice that the Lastorus fossils are both in Africa and in India. Okay, and notice that these Glossopteritus fossils go from Africa to India, Antarctica to Australia. All those things helped prove his hypothesis of continental drift. Evidence from land figures, as shown in Figure 12, mountains and other figures on the continents provided evidence for continental drift. For example, when Wegener pieced together maps of Africa and South America, he noticed that mountain ranges on both continents lined up. He noticed that European coalfields matched up with coalfields in North America. Evidence from fossils. Wegener also used fossils to support his argument for continental drift. A fossil is any trace of an ancient organism that has been preserved in rock. For example, the Glossopteris was a fern-like plant that lived 250 million years ago. The Glossopteris fossils have been found in rocks in Africa, South America, and Australia, India, and Antarctica. The occurrence of Glossopteris on the widely separated land masses convinced Wegener that Pangaea had existed. Other examples include fossils of the freshwater reptiles Mesosaurus and Lystarosauruses. These fossils have been found in places now separated by oceans. Neither reptile could have swam great distances across salt water. Wagner inferred that these reptiles lived on a single landmass that had since split apart. Okay, so you can see now that there's a lot of distance between them, but the fossils remain the same. Evidence from climate. Wagner uses evidence of climate change to support his hypothesis. As the continent moved toward the equator, its climate became warmer. As the continent moves towards the poles, the climate becomes colder. But the continent carries with it the fossils and rocks that formed at its previous location. For example, fossils of tropical plants are found on Spitsbergen, an island in the Arctic Ocean. When these plants lived about 300 million years ago, the island must have had a warm and mild climate. According to Wagner, Spitsbergen must have been located closer to the equator. Geologists found evidence that when it was warm in Spitsbergen, the climate was much colder in South Africa. Deep scratches in rock show that continental glaciers once covered South Africa. Continental glaciers are thick layers of ice that covered hundreds of thousands of square kilometers, but the climate of South Africa is too mild today for continental glaciers to form. Wagner concluded that when Pangaea existed, South Africa was much closer to the South Pole. According to Wagner, the climates of Spitsbergen and South Africa changed because the land masses had moved. Wagner's hypothesis rejected. Wagner attempted to explain how continental drift took place. He suggested that the continents plowed across the ocean floors. Unfortunately, Wagner could not prove a satisfactory explanation for the forces that push or pulls the continents. Because Wagner could not identify this cause of continental drift, most geologists rejected his idea. For geologists to accept continental drift, they would also have to change their ideas about how mountains form. In the early 1900s, many geologists thought the mountains formed because the Earth was slowly cooling and shrinking. According to this hypothesis, mountains form when the crust wrinkled like the skin of a dried-up apple. Wagner said that if these geologists were correct, the mountains could be found all over Earth's surface, but mountains usually occur in narrow bands along the edges of continents. Wagner developed a hypothesis that better explained where mountains occurred and how they form. Wagner proposed that when continents collide, their edges crumble and fold. The folding continents push up huge mountains. All right, today your assignment is Section 3 assessment. I will see you all tomorrow. Bye.